Bismillahirrahmanirrahim. Welcome students. Today we will do Article 2.5 Graphical Analysis of Motion. In today's lecture we will discuss speed time graph. The gradient of the graph gives us the magnitude of acceleration and we will calculate the area under speed time graph to determine the distance traveled by the moving object. So how to plot a speed time graph? As already discussed, a graph requires variables. Variables are those quantities along which a graph is plotted. There are two variables, dependent variable and independent variable. In speed time graph, there are two variables, speed and time. Speed is a dependent variable and time is an independent variable. The gradient or the slope of the graph will give us the magnitude of acceleration that we will calculate using the formula change in speed by change in time, whereas change in speed means final speed minus initial speed. Change in time refers to final time minus initial time. And if the motion of the body is uniform, then area will be calculated using appropriate formula for geometrical shapes represented by the graph. So a slope tells us a lot about the type of acceleration. The steeper the slope, the more the object is accelerating. Acceleration is a description of relationship between speed and time. In short, it is the change in speed over time. In the first picture, we can see a horizontal line which is parallel to time axis along x-axis. The straight line that is parallel to time axis represents constant speed of the moving object. Constant speed means that a body has covered equal distances in equal time intervals. It means it has zero acceleration. The picture below to the left is a graph of an object moving with uniform acceleration. And a picture below to the right is a graph of a moving object with uniform deceleration. So let's suppose you're standing on the ground, you're an observer, and you observe an aeroplane flying above you. At time t0, you started observing the aeroplane that it was moving with a speed of 20 meter per second. Then after every 5 seconds, you noticed or you observed the speed of an aeroplane. And after every 5 seconds, you observed the speed of the plane did not change. It was 20 meter per second. Hence, you draw this table. At time t0, you started observing the plane and it was moving with a speed of 20 meter per second. Then after 5 seconds, again 20 meter per second. 10 seconds again 20 meter per second, 15 again 20 meter per second, and so on and so forth. You plot a graph, speed along y-axis, time along x-axis, taking the values. Now let's see. At time t0, you're going to put a dot over here, 20 meter per second. That was the speed that you observed. Then at 5 seconds again, when you observed, the speed was 20 meter per second. At 10 seconds, you again observe the speed as 20 meter per second. So you will be using a pencil and a scale to draw a dotted line and obviously a corresponding line from y-axis. You will get the dots, then you will join the dots and you will get a straight line which will be parallel to x-axis. As already said, the graph gives us the magnitude of acceleration and the area under this gradient will give us the total distance covered by the object. Now let's calculate the values. Acceleration means change in speed by change in time, or you can use the formula which you have been using in previous classes, y2 minus y1 over x2 minus x1. I'm taking any 2 points on the graph. You can also try and take any points that you like on the graph. It can be an initial value and a final value. It can be points in between. Now my A point over here corresponds to x1 and y1, B, x2 and y2. If you see, my y2 and y1 corresponds to the same value on y-axis, which is 20. However, b point x2, if I look at x-axis, it corresponds to 20 seconds. And over here, my a point x1 corresponds to 10 seconds. I'm going to put the values 20 minus 20 by 20 minus 10 is equal to 0 by 10. And then you get the answer of 0 meter per second square. You can pause this video for a minute, and then you can do calculations by taking any 2 points on the graph. Now the area under the gradient will give you the distance covered by the object. If you see the area under this gradient, this is basically a geometrical shape of a rectangle. In previous classes, you have learned the formula for area of rectangle, which is length into breadth or base into height. So this is your base, which is 25, and your height, the maximum height that you noticed, the maximum speed that you noticed, that was 20 meter per second. So when you multiply them, then S and S, it cancels out and you're left with 500 meters. So the slope of this graph is giving me an acceleration which is 0. Theoretically speaking and mathematically speaking, yes, it is 0 meter per second. And the area under the curve or the gradient is giving me, not the curve, the gradient is giving me the distance covered by the object, which is 500 meters. Now let's take another example. Suppose there is a cycle race and a cyclist is participating in it. At time t0, you observed that the speed of the cyclist was 0. He was at the starting line. Then, when the race started, after every 5 seconds, you started observing the speed of the cyclist. And after every 5 seconds, its speed increased. At 5 seconds, it was 10 meter per second. Then after 10 seconds, you observed that its speed went to 20 meter per second. Then after 15 seconds, it was 30, and so on and so forth. You plot a graph. 0 is covering for both speed and time. 5, 10, 15, 20. You plot all the time values along x-axis and you plot all the speed values along y-axis. Now you take a pencil and a scale and then you start drawing the lines. Since it says for 0 at time t0, v is 0, speed is 0. So you're going to put a dot over here. Then at time 5, speed is 10. So you will extend this line. You will take a pencil and a scale. You will extend a dotted line. And then you will look at the corresponding line on y-axis. Wherever the 2 points are going to meet, you will put a dot over here. Then at time 10, speed was 20. Again, you will take a pencil and a scale. 10 from y-axis, you will take 20. Wherever the 2 points meet, you will put a dot. Then at 15, it was 30. So 15, you will extend a line. From 30, you will extend a line. Wherever the 2 points will meet, you will put a dot. And so on and so forth for 20 and 40. Then you will join the dots and you will get a straight line. Now let's find the value of acceleration using the gradient, and the area under the gradient will give us the distance covered by the cyclist. Take any 2 points on the graph. You can take this value or any 2 points. I'm taking these points A and B. You can pause video for a minute and then you can do your calculations as well. In uniform graphs, whatever points you take, the value of acceleration remains the same. So you can even verify my values as well. So you will use the formula change in speed by change in time. That is equal to y2 minus y1 over x2 minus x1. So my y2 over here is 30. The B point will show me values of x2 and y2. So my x2 from x-axis is going to be 15. My y2 from the y-axis is going to be 30. Then A point shows x1 and y1 values. So my x1 from x-axis is 5 and my y1 from y-axis is 10. I will use these formulas. I will use these values and will put in the formula 30 minus 10 by 15 minus 5. And solving it, I will get a value of 2 meter per second square. Area under the gradient will give me the distance covered by the cyclist. So if you see over here, this green line, this green shaded area, this will give me the distance covered. I will be using the formula of the triangle because you see the geometrical shape I'm getting is of a triangle. As already learned in previous classes, the area of triangle is equal to half into base into height. So half, I'm not going to do anything with that, but for base, yes, I will use the formulas. This is your base, and the maximum value over here is 20, and my height, the gradient, that is 40. So I'm going to put the values 20 into 40 divided by 2. I will solve it and I will get the answer of 400 meters. That is the distance covered by the cyclist. Now, let's see another example that when the motion of a car is decelerating. Let's suppose car was moving with 40 meter per second, and at time t0 you observed it and it was moving with 40, and then after every 5 intervals you noticed that its speed decreased. After 5 seconds you observed that its speed got 30, then after 10 seconds you saw it was 20, then after 15 you saw it was 10, then after 20 seconds you saw it was 0. So basically the speed is decreasing. You plot a graph, you take time on x-axis, you take speed along y-axis, and then again you take a pencil and a scale and you start drawing these points on the graph. So at time t0, your speed was 40, so at time t0, you will put a point over here because it's 40, yeah. And then at time 5, speed was 30, you will take a dotted line, you will draw a dotted line from x-axis, and correspondingly you will along 30 you will take a line, and wherever the two lines will meet you will put a dot. Then again at time t 10 seconds, y-axis it's 20. According to your observation table, you will put a dot over here. Wherever the two corresponding lines will meet, you will put a dot. And then you will join the dots and you will get this sort of a graph. Now we will be calculating the magnitude of acceleration and the distance covered by the car. You can take any 2 points on the graph. I'm taking these 2 points. You can again pause the video and find the deceleration at any 2 points, the maximum and the final or the minimum points, or any points between. So the formula is change in speed by change in time, y2 minus y1 over x2 minus x1. Again, my a over here corresponds to the values for x1 and y1 on the graph. My b point corresponds to x2 and y2 values on the graph. X1 over here, I have to look for x1 on x-axis, which will be 5. And y1, for y1 values, I will have to look at the y-axis, which is 30. Then x2 over here is 15, and y2 correspondingly on y-axis is 10. We'll be using these values in the formula, and my answer comes out to be minus 2 meter per second square. Minus sign over here represents that yes, my body is decelerating. Yeah, my body is decelerating. So area under the gradient, it's the shape of a triangle, and as I've already learned in previous classes, the formula for area, half into base into height. You will be using the values. Base over here is 20, maximum value over here along y-axis is 40. You will be using these values, and my answer is going to be 400 meters. Let's consider an example. If you see from the graph, this first line, this gradient over here is showing uniform acceleration, then it's showing constant speed, there is no acceleration. And then in this half of the interval, you can see that the body is uniformly decelerating. It is decelerating. So What are the values that you have to find? You have to find the acceleration during the first 10 seconds. You have to find the deceleration during the last 2 seconds, the total distance traveled, and the average speed of the car during the journey. If you see, time over here is given in seconds, speed over here is given in meter per second. I just didn't write many values because this was the main value that I was interested in. Okay, so you need to consider the lines in between, that between 0 and 10. What does the small one division corresponds to? So it corresponds to 2 seconds, then 2, 4, 6, 8, 10, then 12, 14, 16, 18, 20, then 22, 24, 26, 28, and 30. So each division over here corresponds to 2 seconds. You have to find the acceleration during the first 10 seconds. So from 0 to 10, then you will take a pencil and a scale and you will drop a dotted line on the gradient and then corresponding line on y-axis as well to see the values. Now you have to find acceleration. Oh, I've done the calculations. Okay. So you have to find the acceleration, final speed minus initial speed over final time minus initial time, or you can use the formula y2 minus y1 over x2 minus x1. Over here, my value is it's going to be, yeah, this is going to be, let's suppose this is a and this is b, and these values will correspond to x2 y2, this will correspond to x1 y1. So x2, if I want to see, or the final speed at the end of this, yeah, at the end of this uniform acceleration, that is 16, and corresponding value on x-axis, it's 10. Time is 10, so 16 by 10. And my initial speed, since the car started from rest, so my speed and my time, I started observing time when car was at rest, was 0. So I'm just going to write x1, y1 as 0, 0, or initial speed or initial time as 0. So my answer is going to be 1.6 meter per second square. Then second part was, what was the second part? I forgot. Okay. This B part was deceleration during last 2 seconds. Okay, deceleration during the last 2 seconds. So 30, and then this line over here, since each small division corresponds to 2 seconds, so this division over here is 28. So okay, so this division over here is 28. You will take a dotted line, drop it on the gradient, and then you will see the corresponding line on y-axis. So it's 30 minus 28, and over here, speed throughout is, this point over here. At this point, the speed is 16. These are my initial values. Just forget about the rest of this. Just consider this graph. Yeah, this line during the last 2 seconds you have to see. You don't have to see the constant speed and the uniform acceleration. So this point is your initial point now, and this is your ending point or final point. So the initial point, at the initial point, your speed is 16 and your time is 28 seconds. And at the end, my speed is 0. If I see over here along y-axis is 0, and my time is 30. So I'm going to put the values of, yeah, final speed 0 minus initial speed 16, final time 30 minus initial time 28. I solve it, I get the answer of minus 8 meter per second square. This should have been a minus sign because, as already the question says, that what is the deceleration during the last 2 seconds. So yes, I was expecting a minus sign. Then C part, total distance traveled. Let's see the total distance traveled. You have to take the geometrical shapes. You will, since you have this geometrical shape, then this geometrical shape, and then this one. What you can do is, there are two ways of calculating the distance traveled. Either you divide this shape. You first calculate the area under this part, then area under this part, and then area under this part, and you add them up using the area of triangle, then over here rectangle, then over here triangle. You can add them up. Okay, in the end, you calculate S1, S2, S3, and then you add them up. Or what you can do is, you can do that. You can apply the formula for trapezium. So the formula for trapezium is half into sum of parallel sides into height. Half, obviously, you can't change it. And then sum of parallel sides into height. Height, the maximum height of the gradient, it's 16. You will write 16 over here. Sum of parallel sides. Obviously, this side and this side are not parallel, okay? But this line is parallel to time axis. So they're talking about these two parallel sides. We have to sum them up. So the value over here, let's see. Over here, my value is this line, this parallel line. Now I'm going to see the parallel lines from 0 to 30. So my one parallel line is of 30, and my second parallel line is from, if I see the dotted lines, they are helping me out. So I will take it as 0. Yeah, I will take this value as 0. I will consider it as 0 and I will count the points. So it's 0, 2, 4, 6, 8, 10, then 12, 14, 16, and 18. So my this parallel line over here, these dotted lines are helping me out. So this is 18. Okay. So 18 plus this parallel line over here, 30. 18 plus 30 multiplied 16 is 384 meters. And you have to find the average speed. Average speed is a simple formula for it is total distance by total time. You already calculated the distance, 384. Total time over here in the graph, you can see it's 30. The total time that the car took moving, starting from rest, then with a constant speed, then decelerating, coming to rest, that was 30. So you will divide 384 by 30 and you will get the answer of 12.8 meter per second. This is the summary of today's lecture. Uh, the slope is giving you a lot of information. From the slope, you can find the magnitude of acceleration. This line over here shows uniform acceleration. This line, constant speed. This line over here, deceleration. And the area under the gradient gives you the distance covered by the moving object. You have to revise the lecture. I will share a worksheet with you all in the group. So please do solve that worksheet. And if you still have any queries, you can contact me on my WhatsApp number. Take care. See you in next lecture. Allah Hafiz.